All right, so now for something completely different. If you get a chance, email me what that reference is about, and I'll give you some extra credit. And now for something completely different reference. This is parametric equations. So what's up with parametric equations? Well, hey, somebody throws a rock at me, misses, hits the ground, whatever. How do I describe that? Well, that's some sort of negative ax squared. Maybe there's a bx in there, and they let it go from 5 feet high. So I know that's the 5 feet right here. Great. So I described the motion, and then you would say, yeah, but how long did it take? So I don't know, but I described the motion. Like, well, no, I need another parameter. It's not parameter, it's parameter. I need time. And if you've taken physics and you get all those equations, they're all parametric equations, but you were never told that. They were just like, here's a formula, have fun. So we're going to parameterize things, right? This is challenging, but not for calculus. I cannot overstate this. People get real jacked up because you've been taught math in a very disjuncted way where you learn all these skills, and we're actually going to bring a lot of them together in calculus. For example, partial fractions. Hey, we're going to learn to do partial fractions. Why? Shut up and do what I tell you. Okay. Well, now we're actually going to use that, I think, in Unit 7, where we use it for integration. Same thing with this. Hey, here's parametric equations. Why? Just shut up and do it. Well, here's a good reason why. It's in physics, but also it's going to be in calculus to describe functions that aren't functions. We can break them into parameters, and each one of those is a function. Hey, we can do calculus, and it works, which is really, really weird. Well, let's talk about how it works. All right. So we set up a coordinate system, some tick marks, and way back to 7th grade, 6th grade, 8th grade, we go. Now we're given a parameter, so that's the first column. So what's going on when t is 0? 0 and 0. What goes on when t is 4? Why would I jump to 4? Because of the square root thing. Well, then x is 2 and y is 4. What about 9? Probably should have done 1 now that I think about it. Well, square root is 3, and this is 9. Oh, well, that's interesting. So 0, 0 is a point. We don't plot the t column. We just plot x and y. Well, then how do we show t? I'm getting there. And then 2, 4 is a point. 1, 2, 1, 2, 3, 4. I happen to know this is a parametric, so it does a little, pardon me, a parabolic, so it does a little this. Well, we have to indicate the starting point. And we have to indicate arrows. Wow, this is going to be tough to do that on the AP. You don't have to do it on the AP. You only have to do it for me. You need to understand how parametrics work. The AP part of it is simple. Really, really simple in calculus. But you should know this. You should understand what's going on. Starting point, I'll often put a little SP in there. There is no finishing point because it just goes up and ever, forever and ever. We can just say where's t equals 0. And notice how important the domain I, which is the parametric interval, which is this right here. Okay, that's absolutely critical. That just kind of sets everything. All right. So we got a definition down here. Those are parametric equations. I don't know what to say. Now we get nasty where we say, all right, let's take something and parameterize it or break it down. Yeah, it's not a big deal. You won't have to do it on the AP. We're just trying to get you comfortable with this so you don't panic about it. I might make it a little more challenging in this class, but we'll see how it goes. So notice the direction matters. The parameter t determines where the curve starts and ends. All right, so here we go. Let's graph. Beginning and end to the parameter. So t, by the way, I don't usually leave this much space in my note packets, but I did this on purpose because first time you got to make sure you know what you're doing. And let's just pick some things here. Pi, and then go to 2 pi. I could go 3 pi over 2, but x is 2, 0, negative 2, 2, 0, 2, 0, 0. Okay, so at time 0, we're at 2, 0 here, right? So this is starting point, also known as t equals 0. At pi over 2, we are at 0, 2. And a lot of people go, oh, 0, pi over 2, I get it. No, 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 no. That's coincidence. Doesn't have to happen that way. It does in this case, right? 0, 2 here. I happen to know this is a circle, otherwise you'd draw a straight line. And I put the arrow in there to indicate which direction it's going. I'm going to keep going. Oh, I missed. Well, this is hard. Don't give me a hard time if you've never done this before. Now my OCD kicks in. Ah, there we go. I feel so much better about myself. And arrows. Now 2 pi is back to 2, 0. So this is also the ending point. Oops. T equals 2 pi. So you have to be able to describe it. It starts at a certain part, ends at a certain spot, so on and so on. Hey, you know what? That looks like a circle. Okay, well, let's square it both. X squared equals 4 cosine squared t. Y squared equals 4 sine squared t. X squared plus y squared equals 4 cosine squared plus 4 sine squared, which equals 4 times cosine squared plus sine squared, where x squared plus that equals 1. X squared plus y squared equals 4. Hey, that's a circle. And you might say, well, why didn't you just say that in the first place? Because there's other things on here that matter. Never see this graph like this on the AP exam, ever, ever. But you should know how it works. You just should. More practice. All right. Now, gonna be a little lazier on this. Hey, it happens. You get older, you get a little bit lazier. What are you gonna do? I know the end of the story, so I'm cheating a little bit here. Let's see, put in 0. Cosine of 0 is 3. 1, 2, 3 here. And 0. So here's our starting point. Put in pi over 2. Cosine of pi over 2 is 0, 1. So we get 0, 4. Oh, so this is a circle. Wait a minute, it only goes over 3 and up 3. Over 3 and up 4. Seems a little bit odd. So again, by the way, I don't know if I've ever seen this done with the starting point and ending point. That's just what I do. And they usually call it a terminal point. What did I put EP up here? It's fine. Terminal point. Starting point, and that is 0. Oh, goodness gracious. T equals 0. T equals 2 pi. So there it is. How did we do that? I don't know. Let's see if I can figure this out. I probably can't. X over 3 equals cosine of t, and y over 4 equals sine of t. X squared over 9 equals cosine squared t. Y squared over 16 equals sine squared t. X squared over 9 plus y squared over 16 equals, I hate it when my equals aren't perfect, cosine squared over t plus sine squared over t. Hey, that's 1. Hey, I know what that is because I took conics in algebra 2. And if I didn't, boy, have I got problems in my hand. That is an ellipse. Pretty cool. Funny how the parametric stuff we're doing has a lot of trig in it. Wonder why that is. Is this a function? Are these functions? We can do calculus to functions. So we break up and make it that, we can do calculus. Pretty slick. Okay. So must be conics. Yeah, no, we can do a line segment. We do whatever we want. Right? This one took me a little while to get good at, but fortunately I'm here to guide you. Line segment, try to identify the graph, the parametric curve, x equals 3t, blah, 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 blah. Well, let's remove the parameter and then pay attention when we do it. Hey, I got the t. Y equals 2 minus 2 times x over 3. Y equals negative 2/3. Oh, goodness. X plus 2. Why did I write it like that? Because I'm an idiot. Alrighty. So it's negative 2/3 plus 2. 1, 2, 1, 2, 3. Wow, it's like I know calculus sometimes. Algebra. So let's plug in 0, 0, and 2. So there's the starting point. By the way, I don't think I did this on my in my previous notes. So yeah, actually I call this the initial point sometimes. It doesn't really matter as long as we're being clear. And then it comes down to here. Well, let's see when that happens. Let's plug in 1, 3, 1, 2, 3. Cool. 1, 2, 3. Hey, look at that. It's a straight line. Unlike what I just drew. Oh, that's embarrassing. I'm gonna have to start this whole video from scratch. Now I'll get by. Oof, that was hideous. Forgive me. So this is the terminal point. T equals 1. All right, so we made a straight line with it. Cool. All right, so I can make you jump through some hoops here. Here's the worst things in the world. I think we can do this for parameterizing points and figure out A and B. Y equals C plus dt. I get to pick that, what was it called? Some weird word, interval, I? Yeah. I'm gonna go with 0 to 1. Why not? But it's really easy with the 0 because it gets rid of some of these. Let's say this is t equals 0. By the way, I am flying by the seat of my pants here. I'm not really sure what I'm doing. And this is t equals 1. Okay. X is negative 2. A plus B, darn, 2 variables times 0. Sweet. A equals negative 2. Now do the other one. 3 equals A plus, 3 equals negative 2 plus some B times 1. Add 2 over 5. B equals 5. X equals negative 2 plus 5t. Now you might be like, why not just put it, sorry about that. You might be like, why not just put it in slope intercept? Why not put the 5t first? Because that's how cool people do, you know, parametric. It looks really tough. Here we go again. 1 equals c plus d times 0. Nice. C equals 1. 5 equals 1 plus d times 1. D equals 4. Nice. And then y equals 1 plus 4t. Which point you scream, hey, I'm done. At which point I scream, no. 0 less than equal to t less than equal to 1. But you say it's a line, it goes forever. Why would you just limit it? Is it a line? Does it go forever? Line segment. Damn it. For those who haven't heard, this is where we have to RTFQ. Read the full question, RTFQ. It looks a lot like not D, but it is. Some people use a different word for F. I won't get into that right now. So here we go. We said it's a segment and this works. What if I wanted to make this 0 to 10? Well, you could. You just change the numbers. So when I do this on a quiz and it's totally different, you go and check it by hand, it takes you a half hour, that's still correct? Yeah, absolutely, that's correct. But I'll be hunting you down in the hallways to smack you over the head for wasting my time. But no, it's correct. That's it. Truly happy mathing.